Very good morning, learners. So myself Rahul NK. I'm a structural engineer as well as I'm working as an assistant professor in the engineering college. So I have my own consultancy where I have done the lot of projects as well as I'm working in the field of engineering teaching field from past 3 years. Uh, I'm starting a new lecturer videos in the Udemy platform, right? The name that I have given or I have chosen is the ETABS, is a practical approach to RCC design. So before I move on to this, first I would like to make you very clear that why I have chosen again this topic, because you know in the Udemy platform you have various lecturer videos on the ETABS. But when I was going through those lecturing videos, the main thing that I have observed is everybody teaches you how to model, how to apply the loads, how to analyze them, how to get the results. Everybody explains very beautifully, but how to relay or how to connect that with a practical approach is lagging behind. So by keeping that point in mind, my main aim of this lecture series is to make very clear to each and every students who pass out from the engineering, as well as I can even sometimes add the who pass out from the MTech or masters also. They should know how to connect the ETABS software as well as how to connect that results with the practical difficulties and how to design it. Because if you open the YouTube, you will get n number of lecture series on the modeling of buildings in the ETABS. So there is nothing any difficulty in that. It is very easy for everybody to learn the modeling of buildings in ETABS. But how to analyze them, after analyzing how to get the results, and after getting the results how to design them, how to design the structure based on the results that you got, right? So and not only that, you know, the software is completely prepared or developed by us only. It is a man-made product. So the software will give you the results for the input whatever you have given. It means if the input given by you is wrong, definitely the output will also be wrong. So therefore, not only learning about the modeling in the software, you should know how to apply the values or the loads or everything in a proper manner. So then only you are going to get the proper output. Once you get the proper output, you are supposed to properly utilize that, and with the help of the other some simple softwares, you are supposed to design it. And even though the ETABS give you more accurate answers, right? So for the sake of safety side, so even we are supposed to design as per the codes in the Excel sheets also, right? So then only we are supposed to be very confident that my design is optimum design and my design is very safe, right? So this everybody should understand very clearly. By keeping these things in mind, I'm starting the new lecture series, that is ETABS, the practical approach to RCC design. Right? Now here, if I want to give you the brief outline that what I have done, I'm going to consider 3 to 4 plans. They are the real practical plans. What I have done in my consultancies. So they are the real plans. So I'm taking one by one plan. So from the simple plan, I'll go to some complicated plans. So from the plans, how you are supposed to first develop the plan as per the client's requirement in the AutoCAD. Okay, so that is the first part that I'm going to teach. Then, in case if the architectures directly give you the architecture drawing to you, as an engineer or especially as a structural engineer, you should know how to read that drawing. So I will teach you how to read that architectural drawings. After reading, so what is my next step? how I am supposed to model it in the ETABS. After modeling, what are the things that I have to consider and I have to apply the loads. And after applying the loads, so what is my next step that I have to analyze? After analyzing, I have to get the results. Whatever the results I get from the ETABS software, I'll again consider that in the Excels. Means I have to design the Excel sheets for the design purpose. How to develop the Excel sheets, that also I'm going to teach you as per the IS codes. So once the Excel sheets are designed, so how to import these software values to those Excels and get the design results. So from the design results, you are going to design the structures. After that, for any contractor or a site engineer, you are not supposed to give it in terms of the values. The best mode of communication in engineering is drawings, or what we call it as detailing. So after that, whatever the designs you specifications you have obtained for the given structure, so how you are supposed to give that design details in the form of drawings and detailings, which will be executed in the site. So in this way, I'm going to follow the path and I'll explain you everything for 2 to 3 or 3 to 4 residential as well as the commercial buildings. Starting from the normal residential building or commercial building to little bit complicated residential or commercial buildings. Okay, so this is my brief outline. So now before we start, so we have to understand some basic things. Okay, so you can see here the next what I wanted to explain is ETABS, the practical approach to our RCC design. Now whenever you want to start a particular design, okay, let us assume that you are a structural designer. So from the architect, you got an architectural plan based on the client's requirement. Okay. One thing I should make you very clear that if you go to some well-established companies, the client is going to deal with an architect. He is not going to deal directly with the structural engineer. There will not be any direct relationship between the architect, between the client and the structural engineer. The client will go to architect. So whatever the client's requirement is there, based on the client's requirement, the architect is going to prepare the plan. Not only one single plan, he'll prepare 2 to 3 plans. And out of those plans, the client will decide any one most suitable plan as per his wish. Once the particular plan is decided, that plan will be given to the structural engineer. So based on that plan, the structural engineer will start designing the given structure, whatever is given to him. Then from the structural engineer, it will go to the plumbing and electric department where they include all their drawings, plumbing and electrical drawings. And once everything is finalized, finally it will be moved to the site engineers for the execution purpose. This is what usually in a well-established consultancies it will be followed. But if you go to the small taluks where there is no any proper consultancies like this, usually the client will directly go to the engineer, right? So as an engineer, even you should know how to plan. Okay. Okay. So now let us assume that everything is ready as per the client's requirement. Now, if you want to start the design, the first and the foremost step that you should know, okay, the first and the foremost step that you should know is the safe bearing capacity of the soil. Please keep it in mind, students. If you are a very good structural engineer, without the safe bearing capacity of the soil where you wanted to start your project, you will not take up a next step at all. Because from my experience, I'll tell you, most of the people feel that finding the SPC of the soil is useless. But no. Okay? I'll tell you very frankly that whatever the amount you spend in order to find out the safe bearing capacity of the soil will saves you almost 70 to 80% of the amount that you are going to invest in your project. I have seen most of the clients, they are very reluctant to spend at least 50 to 60,000 in order to calculate the safe bearing capacity of the soil. They feel that they are going to waste that amount, but no. If you don't have the proper safe bearing capacity of the soil, even the structural engineer or a normal engineer will be in the dilemma that whether the SBC I have taken is enough or not. Is it sufficient or not? He will not be having much confidence. Therefore, what he'll do, he'll take up the minimum SBC and he'll start doing the design. That leads to very huge designs, which is uneconomical designs with the huge reinforcements, with the huge members dimensions, right? So if you compare the cost, the client, whichever he is going to pay for that amount, will be much more higher than that what he is going to spend for the SBC. That's why if you are a true engineer, you should be in a position to convince the client that no, SBC of the soil has to be done. Okay, so if you exactly or thoroughly know the SBC of the soil where your project is going to be done, it's well and good. You can take that SBC and you can start the design. But if you have a small doubt also, you have various methods to find out the SBCs of the soil. By doing the various methods, you can find out the SBC and you can start your design. The one of the most convenient method is plate load test, where each and every engineering college, not only engineering college, even in the diploma colleges also, the plate load test apparatus will be available. You can bring it into the site, right? And you can get the SBC of the soil. So that will not cost you more than 50,000. That is max if the site is very far from the very far. Otherwise, it will not cost you more than 30,000 also. That saves the lot and lot of amount in terms of lakhs for your project. So therefore, the first step is you are supposed to decide the safe bearing capacity of the soil. Okay, so from the various methods and everything after that, you are going to get the exact SBC of the soil. Then what is my next step? My next step is I am supposed to find out the depth of the foundation. Okay, so everything again I am going to explain in detail when I am going to start a particular design with the help of one particular plan. Now I am just going to briefly give you the outline, right? Okay, the second step that you are going to do is depth of foundation. Now once the SBC of the soil is come to know, based on the some empirical formulas what you are going to get. So with the help of those empirical formula, you are supposed to find out the depth of the foundation. You are supposed to find out the depth of the foundation, right? From the ground level to what depth your foundation has to start. Whether it is 2 feet, 3 feet, 4 feet, 5 feet, based on the SBC of the soil, you are going to decide that. Okay, if the value of the SBC is higher, so definitely the depth of the foundation required will be very less. If the SBC of the soil is very less, the depth of the foundation required will be very high. Okay, so based on the SBC of the soil what you are going to get, you are supposed to find out the depth of the foundation. That is my second step. So once the exact depth of the foundation is known to you, okay, once the exact depth of the foundation is known to you, my third step is the center line marking. Okay, on the plan given by the architect to the designer, mark the center line of the columns, the temporary column position both horizontally and vertically. Now once the SPC is found out and once you calculate the depth of the founding, so definitely after the client's selection, you will be having one plan with you. Now, what you are supposed to do, sometimes the architect itself will give you the position of the columns and beams based on the client requirement. Or sometimes the architect may give you only the plan without giving any positions of the beams and columns. If the positions of the beams and columns are not given to you, then it is the duty of the structural engineer to decide the positions of the beams and columns. When I'm going to take one particular design, I told you I'm going to take 2 to 3 plans. So I'm going to take in such a way that some plans will be having already the positions of beams and columns. Some plans will not be having anything. Both kind of projects I'm going to consider. Okay. So if you have, okay, it's well and good. You can try to design that with that only, but it is not mandatory that whatever the positions of the beams and column the architect has given, you are supposed to follow that only. No, it is not like that. As an structural engineer, you have the freedom to change, but make sure that the plan given by the architect should not change, because it will be done based on the client's requirement. So your first and foremost aim is to satisfy the client. You should not dissatisfy him. So without changing anything in the plan, you have freedom to change the positions of beams and columns. If it is given to you, then you can go with that, and you can check whether that positions of the beams and columns are okay, whether it is under safe or not. And one more thing, keep it in mind, they are not permanent, they are temporary. We have the option to change even at the last moment of the design also, and there will be many cases where you have to change because of lot of constraint. You have to change it. Okay, but initially, in order to start our design, we have a rough positions of the beams and columns. So once the rough positions of the beams and columns are decided, I have to do the center line marking. What is that center line marking? How to do everything we will see in the, when I take up the problem, when I take up the plan, I am going to explain you the center line marking. Okay, if you want, I'll just show you one rough sample here. Okay, you can see for the first problem I'm going to consider this plan, right? If you take this plan, so the architect has already given me the dimensions of the columns. These are the columns and these are the beams. Okay, this is the plan. So for this plan, what I am supposed to do, I am supposed to draw the center line, that is I have to connect all the columns both horizontally as well as vertically. This is very, very important in order to select the positions of the footings, right? So how to do it, everything I'll explain in the upcoming lecture videos. But the first step after deciding the positions of beams and column is you're supposed to draw the center lines both horizontally and vertically in order to get the distance between the center line of the columns. In order to get the distance between the center line of the columns. Okay, yes. So if you want, I'll show this also. You can see here, you can see, yeah, you can see here, this is what we call it as center line. You can see here, so I have drawn all the columns centers both horizontally, and I wanted the distance between the center line of the columns. Okay, how it will be done in detail I'll explain in the next upcoming lectures. Okay, yes. So that is my third step, that is finding or drawing the center line markings. The next is preliminary design of the members. Once the center line markings are done on the plan, so we are going to do the preliminary design of member, that is consider the preliminary dimensions of the members. It means in order to do the modeling in the software, we need some basic dimensions. Okay, keep it in mind, student, those dimensions are not final. those dimensions are not final. They are just the assumptions that what we have made. Definitely we are going to change the dimensions, and we will be deciding the final dimensions of the column after analysis. But initially we will be doing some, we are going to assume some dimensions of the beams, dimensions of the columns, dimensions of the slabs. Okay, in the beams again we have plinth beam and roof beam. Okay, so when I take up the problem, I'll explain you what you mean by plinth beam and what do you mean by roof beam. Then I have to assume the dimensions of the column as well as slab. There is some crude method that we usually adopt to decide the preliminary dimensions of the members. That also I'll explain you when I'm going to take up the problem. So my fourth step is I have to assume some preliminary dimensions of the members, which includes beams, columns, and slabs. Okay. Then the next is modeling of the structures in the commercial software. See, when it comes to the modeling of the buildings, you have n number of softwares, that is commercial softwares available in the markets. So I have listed few of them. SAP is also one of the software which is most widely used in the Western countries. ETABS as well as StatBro. Okay, so the one of the best software that you can have for the design of RCC structures is ETABS, whereas for the steel or the trusses, the best software is StatBro, right? So therefore, since I'm doing the RCC design, I have considered the ETABS, right? Okay. So once these dimensions, once the centerline marking, once the preliminary dimensions of the structural members, everything is decided. So we are going to model that structure in the software. How we are going to model, how we are supposed to do everything, I'll explain when I consider the given problem. When I consider the given problem, I'm going to explain. Okay? Yes. So completely we are going to model it. We will be modeling the beams, we'll be modeling the frames, columns, we'll be modeling the slabs. Even if staircase is present, even we are going to model the staircase also. Okay, we are going to model the staircase also. Then we'll be applying the loads. Everything will be done as per IS codes only, Indian standard codes only. We will not go beyond that. Okay, everything will be done as per that. And after that, we are going to analyze it. Okay, even I'll be explaining how to model the structure in the ETABS. Right? Once the modeling is done, as I already told, the next step in the software is I have to apply the loads. Right? Based on the purpose of the building, based on the purpose of the building that we are going to do, we have to apply the load as per the IS codes. Anyhow, for any building, the dead load and live load is must. Okay, so the dead load will be obtained from IS 875 part 1 based on what kind of material you are going to use. Okay, based on what kind of material you are going to use. So based on IS 875 part 1 will give you the dead load of the various construction materials. Based on that we will find out the dead loads. Then IS 875 part 2, IS 875 part 2 will give you the details about the live loads based on what type of building, whether it is a residential building or whether it is a public building or whether it is a commercial building or whether it is an industrial building. Based on what type of building, again in public building, whether it is an hospital or whether it is in any office or whether it is in any government office, based on the nature of the building, so different live loads has been given. So based on what type of building we have considered, we will apply the dead loads and live loads in the software. And even if the structure is present in an earthquake prone zones, even we are supposed to consider the earthquake. That is IS 1893 2002 will give you the specifications about the earthquakes. And even if it is a high-rise building, okay, even if it is a high-rise building, multi-story buildings, very of 20-30 story buildings, then The wind load plays a very prominent role. IS 875 part 3 will give you the specification about the wind loads. And if the buildings are situated in the western countries where the snowfall is a prominent load in such areas, even the snow loads also has to be considered. Therefore, once the modeling is done, the next step you are supposed to apply the loads on them. You are supposed to apply the loads, or you are supposed to consider the loads on them. Okay, so once you consider the loads, you have to apply the loads. Once the application of the load is done, the next step is you are supposed to analyze the model and you are supposed to obtain the results. Okay, so you have to analyze it. So after analyzing, definitely you are going to get the results. Okay, so what type of results you are going to get, what results we are supposed to take, which is required for the design, everything in detail I'll explain you when I take up the problem. So now for this, at this point of, let us understand that we are going to analyze the model. After analyzing the model, I am taking up the results. Once the results are taken back, from that design, from that results, we have to start the final design of the structure. Okay, you can see here the final design of the structure. The final design of the structure means whatever the preliminary dimensions of the members that I have taken, beam, column, slabs, everything. So that may holds good or that may not holds good. If the loads are heavy, that members may get failed. Even the software will tell you whether the members is going to pass or whether the members is going to fail. So if it is failing, then you are supposed to reconsider those dimensions based on the loadings. If the loadings are very less but the dimensions of the members are very huge, then you should not neglect. You have to reduce the dimension because your design should be optimistic. It should be economical as well as safety should be considered. Both has to be considered, right? So therefore, based on the results what you got, you are supposed to redesign or reconsider the dimensions, and you are supposed to finally design the members. Members consists beams, columns, slabs, footings, even staircase. Everything has to be designed as per the IS codes. That means you are going to give the reinforcements to it. You are going to give the concrete to it. That is what we call it as the final design of the members. Okay. Now, before you start the final design, you should do the grouping. What do you mean by that? Let us take one just example I am showing you, students. I am just showing you. You have, for example, 25 columns, right? So, based on the loadings, all the columns will not get exact loadings. Some column may have higher loadings, some column may have lower loadings. Similarly, all the beams will not have the same loadings. Some beams will have higher loading, some beams will have lower loading. Usually, if you start from the floor level, so the loadings on the beams will be higher. If you go to the roof level, the loadings on the beams will be lesser. Right? So definitely, no need to have the same dimensions for all the beams or for all the columns. Right? So what we do, we call that as grouping of members, right? Based on the loadings on the members, we will group the members into certain groups, maybe 2 3 4, or based on number of members also. So group 1 will have certain members where the loads on that will range from certain to range. For example, group 1 will have some columns on which the loadings on the columns will come from 500 to 1000 kilonewton. Group 2 will have some columns where loadings on that will come from 1000 to 2000. So another group will have columns from 2000 to 3000. So like that groupings will be done, right? So based on that range of loading, what we do, we decide the dimensions. For group 1, we will fix one dimension. For group 2, we will fix one dimension. For group 3, we will fix one dimension. What's the reason? This is done in order to make the work easier. Okay? Because each and every column or each and every beam will have different loading. So if you do as per the loading, definitely the dimensions of each and every member will be different. So if you give the same detailing to the site, it is very difficult to cast. So one beam will be having one dimension, next beam itself will have another dimension, means it is very difficult and it is not a good approach also. So therefore what we do, we group the members based on the loading, and for each group we will give the dimension, and that will be maintained throughout in the project. Okay, that is what we call it as grouping of members. Once the grouping of members is done, then only you are going to design it. Okay, once the design is done, as I already told, the ETABS software will give you the direct results, but we cannot completely rely on that. To be on our safer side, we have to verify them with the Excel. Right. So then what you are going to do with the Excel? In the Excel, you are going to develop the Excel sheets based on the IS codes. I'll just show you one sample. You can see here, this is an Excel sheet that I have developed for the design of the columns. Okay. So this will be as per the code. You can see here have this many number of columns, almost 26 columns are there. Right. So based on the loadings, we are going to group them. Okay, we are going to group them. How we are going to do everything, we will see it in detail when we take up the problem. Okay, so like this you are supposed to develop the Excel sheets. You can see this also. Then once that is done, we will give you the reinforcement detailing in the form of Excels also. You can see like this. Okay, so this is for columns, that is for the beams, right? This is the reinforcement detailing of columns. Then this is the reinforcement in detailing of beams. So everything we are going to design in the Excel. Then whatever the design details we got from the software, we are going to cross verify them with the Excel sheet. Once the cross verification is done, finally I told you the best way of communication in the engineering is drawings. If you give this Excel sheet to them, it is very difficult for a site engineer to understand. Okay, so they need in terms of drawings. So therefore, what we will do, we will convert that reinforcement detailings into the drawings, what we call it as detailing. Okay, so proper detailing of the drawings has to be given. Based on that drawings only, the particular site engineer will execute it. Right, I'll show you one small sample. You can see here I have shown them all the details like this. This is the detailing of the column as well as the footing. This is the detailing of the column as well as footings. Okay, yes, you can see here this is the reinforcement detailing, and you can see there is a one footing which is a combined footing. That reinforcement and detailing is there. Okay, this is how the reinforcement and detailings we are supposed to provide. Everything we will explain in detail. Okay, you can see this is the reinforcement and detailing of the beams. This is the reinforcement and detailing of the slabs. You can see here reinforcement detailing of slabs. Then you can see this is the reinforcement detailing of the staircase. Okay, this is what you are going to give them to the site engineers, because based on this only they are going to execute it. Okay, so this is the last step. So just now in this video, what I have explained is the broad outline or the broad procedure that how as a perfect structural engineer has to go to have a proper and the safe design and a detailing of a given structure. Okay. So in the next lecture, I'm going to take up one plan where in that plan already the positions of the beams and columns has been decided. So by taking that problem, I'll start explaining you first and the foremost step how you are supposed to read the given architectural drawing. Okay. So after that, in the every one lecture, I'll explain you each and every step. Okay. So thank you students. So in the next lecture, we will take up one plan, architectural plan, and I'll explain you how to clearly read that and then how to move forward. Thank you learners.